The time, the early 21st century. The place, a scrapyard in Germany. A globalized economy has flooded the world with a myriad of cheap products of ever-decreasing quality and life expectancy. Many of us feel that their lives are increasingly devoid of meaning. We have become the consumers when once we were the producers, engineers, builders and operators of this world. And we all know that this planet's resources are finite, yet we are constantly being told that in financial terms, a repair is just not worth it. Yet we all somehow feel that this is deeply wrong. Let us be the archaeologists of a bygone age then, and let us try to understand and bring back to life the tools and the mindset of a civilization that operated under another paradigm, learning, understanding, and thus reclaiming a piece of meaning to our lives. Let's see what we can find here today then. This looks like a stamping press of some kind. I would totally take this with me, but as it is often the case, the machine is too heavy to transport and also I don't have the space to store it. This generator looks just like my style, but it really looks like a ton of work with parts missing and damages from the scrapyard. Now this looks like a massive metal saw manufactured by Eisele in Austria, and I always wanted to have one of those, so this is totally coming home with me today. The steel clamp here is also a keeper. This machine here has a nice gear motor in it, but I don't have the tools with me to take it out. This table saw is too far gone and probably wasn't of the best quality in the first place, I'm afraid. But what do we have here? A beautiful old phone bell of some kind. And since this is very light, it will be basically for free. So it's a keeper. And another huge machine of industrial quality that must have cost many thousands of marks at one point. But again, too heavy and too big for me. But I also found this AC compressor here from an old window air conditioner, and I will use that in this video to build a silent air compressor. Let's get to work then. I'd say we start with the metal saw today and we can have a look at the nameplate to learn more about it. It's an Eisele brand saw from Austria, model LMS1, that's for Leicht Metall Säge or light metal saw. So in other words, suited for cutting of aluminium, and it was made in 1967. It can be run on 220 volts with a capacitor or on 380 volts three-phase power directly, which is what we're going to do. Let's assess the damage then. The blade guard is hanging loose because one of the two bolts holding the guard has snapped. This steel part was attached to the saw rather unprofessionally by some guy and it will have to be removed. It's all so bent out of shape though that I can't just unscrew it. The fan guard has lots of dents, stopping the motor from running freely. This probably happened at the scrapyard though. This electrical housing is also somewhat dented. The wires are severely deteriorated with the insulation literally falling apart. The wiring has to be renewed completely. There is no saw blade, and worse, the part that is supposed to hold and tighten the saw blade is also missing. There probably were clamps at one point that could be fastened to these holes, and they are missing as well. The saw can be rotated, but it could use some oil. The fastener is very rusty, and so is the entire machine bed. The handle of the saw has also broken off and is missing. Well, I'd say let's not lose any time then and get her done. First, the belt guard is removed by unscrewing the remaining Allen screw. Now you can see the remains of the other bolt that has broken off at some point. While removing a broken bolt can be very tricky, there is one simple method that I try first when the diameter of the bolt is over 5 mm or so. It simply involves a center punch, a hammer and some patience. In order to unscrew this heavily bent bolt. I cut off the steel bar that is attached to it. Now I can simply unscrew it by hand. The switch enclosure is opened. Inside we find sawdust. Maybe a former owner used the saw to cut wood instead of metal. In situations like these, you should always take a picture before removing the wires, or film yourself like I do here. It's much easier then to do the rewiring correctly. Even though here it's quite easy. 3 mechanically coupled switches connecting or disconnecting the 3 phases. A blue wire was used, but in this case that's not the neutral conductor. This machine doesn't require one. The blue wire is instead one of the 3 phases. The wire they used simply didn't have another black, brown or gray conductor left. And we also open the housing for the electrical connections of the motor, and we find once more the standard situation for 3-phase motors. And I tried to explain this in the first episode of the series, but I screwed up my drawing and only saw it when the video was already uploaded. This is how the stator windings are typically connected internally. The brass parts can be used to connect the winding in either a delta or a Y configuration. In this case, it's a Y for what was then 380 volts 3-phase power. To run this on single-phase AC, the brass parts would be rearranged and an external capacitor would also have to be added. Next, I remove the fan guard in order to remove the dents. To my satisfaction, the fan and motor can still be moved easily after the guard is gone. This might be a good point in time to also remove the belt guard and check the belts. In this case, they used 4 of them in parallel. I cleaned them up, and upon a first visual inspection, they still seem to be in good condition. Let's take care of the rust on the machine bed then. After having tried everything from chemical rust removers over electrolysis, sandblasting and wire brushing in various forms, I find myself returning to the same simple method over and over again. Applying WD-40 or some similar product and some careful scraping of the surface with some abrasive fabric. It just works. After removing most of the rust and cleaning the saw all over, the blade guard is reinstalled with 2 new bolts. Then the dented and bent fan guard is straightened out. I do that with little more than a steel rod, a center punch and a hammer. It won't win any beauty contests, but it will give the fan enough space to rotate freely while protecting objects from coming in contact with the fan. By the way, 90% of fan guards you will find on electric motors from the scrapyard are damaged. It's just usually the weakest spot in these motors. Now a new bolt is screwed in here as well. And a new replacement wire connects the motor and the switch, and then of course a new power cord is attached as well, and the switch's enclosure is closed. But here is the next problem already, the broken/missing handle of the saw. I use a wrench to remove the broken off end of the old handle, retrieving the old nut. Now a new handle will be built from parts I found on my shelves. An M12 stainless steel threaded rod and an aluminium tube that is actually a little too fancy for this application. The rod is screwed in and countered with the old nut. Now I'm using the pipe vise from episode 4 of this series to cut off a piece of this aluminium tube. I tighten it with another nut, and there is our new handle. But here are the 2 most complicated problems I have faced with this saw. 1. Ordering a saw blade. That one required to get in contact with the manufacturer, Eisele, in Austria. Comprehending the thick Austrian accent on the phone and paying a lot of money to get my replacement part for a more than 50-year-old saw. But I don't even want to complain that it's expensive. Quite the opposite. I want to recommend them for even considering to sell me a blade for a saw that they made in 1967. The other huge problem was that the part holding the saw blade was missing. So I decided to make one myself. In order to do that, I had to take a trip to heaven. also known as the local metal store, where everything metal is sold. They used their bandsaw to saw off a piece of 80mm aluminium round bar that I took back to my shop, where now, in a premiere of sorts, my metal lathe will have its debut in helping to repair another machine. By the way, I restored this lathe about 2 or 3 years ago, and the videos showing that can be found in the video description below. A center drill was fastened in the tailstock and used to drill into the round bar. Then a 12mm drill bit is used to drill a proper hole where then this M12 stainless left turning bolt will be installed. First I do some work on the edge of this new part to then remove the material in the middle. Then the back side of the disc is machined. And here is a before and after comparison of the raw round bar and the machined part. But here is the problem. The saw blade that the manufacturer sent me is a little too big, and I will have to wait a couple of more weeks until they send me the same blade but a little smaller in diameter. So in the meantime I only can show you the saw in action with a saw blade that I happen to have lying around, but that is not suited for cutting aluminium at this speed. So let me just show you the action of the saw without actually cutting anything. I know it's disappointing to not see the saw in action right now, but rest assured that it will be used many times in future videos. Let's head on to another, simpler repair then. That old adjustable clamp we found right next to the saw. I start by pulling this removable jaw all the way down, taking it off the clamp. And to the I don't know how manyest time in my life I learned that wire wheeling with power drills simply doesn't work very well. Just to switch once more to the heavy angle grinder. Once you have learned how to handle it, you can use it to clean parts that are actually, well, a little too small or fragile. Well, at first glance at least. Its downside is, however, that your arms will feel very heavy in a short amount of time. And again, WD-40 and abrasive fabric. Now, the clamp is oiled. And that's of course how it works. You can clamp really small parts by putting the pack into one of the other holes, adjusting it to the dimensions of wider workpieces. But let's move on to another small object we found at the scrapyard then. This old bell, at least to my knowledge, it's an outside phone bell or extension bell of some kind. The company Wilhelm Heibel seems to be from a town called Röslau in Bavaria. The year it was made was 1971 apparently, even though the design looks much older. I guess it was manufactured to the same specifications for many years. Inside we find two electromagnets and an old capacitor. And thanks to a rubber seal that's in pretty good condition after nearly 50 years, the parts inside are also in a very good state. In order to clean the enclosure, I removed the magnets and the little bell clapper on the back side. It was once installed on a wall, and whoever used to live there didn't bother to cover the bell when painting that wall, which is why it's looking much worse than it could. I'd say this is a case for ultrasonic cleaning. The cleaner here is not mine, I borrowed this from a friend. Maybe I will find one day on a scrapyard, because that's frankly the only way I can afford most of the things I use in my workshop. Normally, you're probably supposed to properly suspend this basket from the sidewalls of the cleaner, but I forgot to do that. However, after just a few minutes, we can already see that the wall paint is coming off, while the original paint seems to be unharmed. And we give it a few more minutes and try the same thing with the enclosure. After everything is dried, I put the parts back together, also installing a new power cord. This bell can run directly on the mains. And after some minutes of adjusting the bells, so after these two rather simple tasks, let's tackle the next major project. This is a 50-liter air compressor by the German company Kesa Kompressoren from Coburg. It was made in 1987 and I've been using it in my shop for around 4 years now. It still mostly works, but has one major downside: it's really loud. And I just found this old AC compressor from a window air conditioner on the scrap, and I want to see if I can use it to convert this very noisy air compressor to a silent one. I will keep the old pump, of course, so in case this all shouldn't work, I can just revert it to the original state. After having disconnected the motor and discharge tube, I lift off the old pump and put it on my shelf. While I'm at it, I'm also trying to remove some concrete that's stuck on the tank. I do that with mixed success. Any good advice how to remove concrete? Any ideas? I also open the drain plug on the bottom of the tank to release water that has collected inside. Even though the compressor is over 30 years old, there is no rust in it, which is rare. The reason for that is, as far as I know, that Kesa pressure tanks are plastic coated on the inside to prevent corrosion. The AC compressor will later be installed here, but in order to do that, a number of preparations are necessary. The old pressure switch was damaged a long time ago and is held in place by hot glue, applied by a former owner because I never use hot glue. The unloader valve has been leaking for years and needs replacement, which I don't have at the moment. I removed the discharge tube, and I also removed the unloader tube because I will simply block the path to the unloader valve until I will have a proper replacement. For our little experiment here, I will use this nut. I close the nut with my TIG welder and screw it on the port. The old pressure switch is removed, and so is the gauge, which is also no longer working properly. Now the AC compressor itself is modified. I will reuse the old metal sheet it is still attached to. It would be no good idea to unscrew the old shock absorbers. They are 40 years old and would probably break at the attempt. A piece of the sheet is cut off though. Then the rust is removed from the compressor's enclosure with various methods. The surface of the discharge tube of the compressor is now sanded with some sandpaper. I first thought that this would be the inlet port, but no matter how you connect the three phases to the three-phase motor inside, this is always the discharge side of the compressor. And the same happens to the inlet tube. And here is a piece of copper tube that I will use to prolong this tube, where I will install an air filter. Over at the blacksmith's vise, a brass angle is prepared and soldered to the tube. And now the tube is soldered to the inlet, and now the air filter can be screwed in. Another piece of copper tube is prepared and then soldered to an old brass hose barb that I found on my shelves. This part is then again soldered to the discharge side. Since the AC compressor has a three-phase motor, I also need a place to install a three-phase relay because I only happen to have a single-phase pressure switch. But more about that in just a minute. Holes are then drilled into the bottom plate to install the compressor on the tank. Further changes are necessary though. Rather than using the old discharge tube, a tiny piece of it is sanded off. Then I sift through my box of old brass parts and see what kind of hose barbs I still have. This one is from an old quick connector. It's supposed to be soldered to the tube, but its diameter is a little too wide. Therefore, the old lathe is again called to action, reducing the diameter a few millimeters. Now the barb can be soldered to the tube near the one-way valve. The AC compressor is now finally fastened to the tank, and a three-phase relay and an additional regulator and separator are also bolted to that piece of aluminium I had prepared earlier. An adapter, a new pressure switch, discharge ports, and a new pressure gauge are also added. Now it's time for the electrical wiring. The compressor is powered by a three-phase induction motor. That's why we have 3 pins here. This is an over temperature switch. So what's going to happen here is that we have a three-phase power cable, you can see it down here, connecting to this three-phase relay. The cable's going in there. And then of course you would hook up the output side, the 3 phases, to this. But the actual pressure switch is just single phase. So what's going to happen is that I take the neutral from the 3-phase phases and then connect one of the phases to the single phase pressure switch, then in line to that the over temperature switch, and then that's going back to the solenoid that actually activates the relay. So in other words, you can turn the compressor on via the single phase switch. Once the pressure threshold is reached, the single phase switch is going to be disconnected, then de-energizing the solenoid on the relay, thus disconnecting the motor from the grid. Now I know that oiling the compressor, refilling oil and getting the oil out of the air again will most probably be a problem with this entire setup. That's why I added the separator that I still had lying around, but I will not use it in this first test. So guys, I really hope that you liked this episode, and in case you want to see more content like this, you absolutely should give this a like. Otherwise, I have no way of knowing that there is demand. If you want to support the future production of these types of videos, please consider donating via Patreon or PayPal. Links are in the description. See you soon, guys.